We have decided to design a flight information display system database intended to support airport and terminal display boards. The primary objective of this database is to address common data management issues such as inconsistent flight status and outdated or improperly synchronized time fields. In many operational environments, discrepancies between scheduled, estimated, and actual times can lead to confusion for both passengers and airport staff. We hope to resolve these issues with our database by enforcing standardized status values, clearly separating time categories, and applying structured constraints. This will ensure accurate and consistent data. Additionally, the purpose of our system is to support efficient querying, enabling well-organized departure and arrival views. Our flight information display system will show a managed structured flight information for an airport environment. Each flight is identified by a flight number and includes operational information such as destination, scheduled departure time, estimated departure time, assigned gate, and operational status. Operational status values include on time, boarding, delayed, departed, arrived, and canceled. Flight times are stored in UTC, Coordinated Universal Time, within the system to ensure consistency across regions and to support accurate time conversions for display purposes.
The system manages airport information, where each airport is associated with exactly one time zone. A time zone may be shared by multiple airports. Time zone data includes UTC offset information and applicable day range to support daylight saving time adjustments where applicable. This allows schedule and estimated flight times stored in UTC to be converted into local display times based on the airport time zones. An airport has a number of terminals, and each terminal contains multiple gates. For a given airport, each terminal has a unique identifier, for example, Terminal 1 or Terminal 2. With each terminal, each gate has a unique gate number, and every gate belongs to exactly one terminal. Each flight is assigned to exactly one gate at a given time, but a gate may serve many different flights over time. Because each gate belongs to exactly one terminal, a flight terminal is determined through its gate attachment. This establishes the first critical relationship, the flight to the gate to terminal relationship. The flight table references the gate table, and the gate table references the terminal table. Through this structure, gate change automatically reflects the correct terminal information for a flight.
The system also maintains airline information. Each airline operates multiple flights, but each flight is operated by exactly one airline. This establishes the second critical relationship, the airline-to-flight relationship. The flight table references the airline table, enabling retrieval of all flights operated by a specific airline or filtering flights based on airline and operational status. Flights must have both a source airport and a destination airport. A flight originates from exactly one airport and arrives at exactly one airport, and each airport may serve as the origin or destination for many flights. This relationship allows the system to track flight routes while maintaining consistent time zone-based time conversions. In addition, unless a flight is delayed or canceled, it must have an airplane assigned to it. Passenger information is also maintained within the system. Each passenger may travel on one or more flights, including connecting flights, and each flight may include one-to-many passengers. This establishes a many-to-many relationship between passengers and flights that is represented by a flies-on relationship table, which records passenger participation on flights and optionally references connecting flights when applicable, allowing the system to represent multi-segment travel itineraries.
Additionally, the project was expanded with a few optional tables to support future features and make testing easier. A passenger table and a flies on table were added to represent the many-to-many relationship between passengers and flights. The flies on table also includes an optional connecting flight ID so the database can show connecting flights and the multi-flight itineraries. An optional airplane table was also added to store basic airplane information such as airplane type and seat capacity. This can support future features like airplane assignments, capacity planning, and reporting. To make the database easier to test and demonstrate, sample seat data was added for airlines, terminals, gates, flights, passengers, and airplanes. Demonstration queries were also added to show important relationships in the system, including the relationship between airlines and flights, and the relationship between flights, gates, and terminals. A time zone conversion query was also added to show how stored UTC flight times can be converted into local display times using airport time zone information and UTC offset date ranges. And this is Charmaine Joy Rains. I worked on the flight information display system with Hayal Roman, Sylvia Wing, and Con Ho. Thank you.